Now we'll solve problem 29.1. You find this problem in Chapter 2, Motion in One Dimension. So this problem relates to an interactive problem in your online book. So to get sufficient information about this problem, we need to refer to that interactive activity. So let's go there. First, I go to the section they are referring to, and then I press the interactive problem. I can see in this problem that I have a red puck that accelerates at a rate of negative 0.289 meters per second square until it stops. So it's slowing down. Enter an initial velocity so it travels 5 meters up to this point and press go. Okay, so I can play with the interactive activity before I start for a while. If I press go now, nothing happens because I didn't put in any numbers for velocity. I will try, let's say, to put in 3. See what happens. Whoop, too much. So I will try a small number, let's say 0.1, and I see what happens. Oh, too little. So now I will press reset and try to solve. So my third guess will be a real solution. So what do I know here? I know the acceleration. I get it right from the problem. I also know that the puck stops, which means the final velocity is 0. I know that they want me to enter an initial velocity. So I need to find the initial velocity. I also know that it travels 5 meters, so displacement is 5, and that's all. So I go back to my solution. I know that acceleration is negative 0.289 meters per second square, and this amount is constant. So this is a problem with motion of constant acceleration. So the 4 formulas of motion with constant acceleration apply. I will put them in front of me, and now I look at them to decide which one I'm going to use. So I want an equation that will give me initial velocity. That will be the first one, the second one, third one, fourth one too. So let's analyze the first one. Do I have delta x? Yes. Do I have the time? I don't. Do I have the acceleration? I do. I have 2 variables in this equation, so I can't use it directly. Second one, do I have final velocity? Yes. Do I have the acceleration? Yes. Do I have the time? No. Again, 2 unknowns, I cannot use it. Third one, do I have the final velocity? Yes. Do I have the acceleration? Yes. Do I have the displacement? Yes. Here we go, we found our equation. We copy it to our solution paper. It's important to write it down first. So I do that, and now I substitute. So Vf is 0 squared. V initial is what I want to find, plus 2. Acceleration is negative 0.289, and delta x is 5. Now I solve for Vi. 2 multiplied by negative 0.289 multiplied by 5 is equal to negative 2.89. Then this means that vi squared equals to 2.89. I take the square root of both sides. And I use my calculator to find it. So vi is positive negative 1.7 meters per second. And it's positive negative because there are two roots, positive one and a negative one. Both of them, if I square them, if I square positive 1.70, it gives me 2.89. If I square negative 1.70, it also gives me 2.89. So I need to pay attention that there are two answers. And now I decide which one to use. So if I use the negative answer, that means my puck is moving to the left. Should my puck move to the left? No. So that's not the answer I'm choosing. If I use the positive answer, that means I'm directing my puck to move to the right. And that's what I want. So the acceptable answer is positive 1.70 meters per second. Okay, I will try that. I will go to the activity and put in 1.70 and see what happens. Looking good. Looking good. Great job. You stopped the puck on the goal line. Thank you everyone for listening.